In this lesson video, we're going to take a look at day 6.2, and we're going to be talking about circle angles, or specifically angles as they're related to circles. There's 4 different kinds of angles we're going to look at. Those are central angles, inscribed angles, interior angles, and exterior angles. But first, we need to really understand what it means to have an angle intercepted by an arc. Okay, and so if I draw a picture like this, if I've got a circle, and I put 2 points on that circle to create an arc. Okay, let's call this arc AC. And you'll notice I draw a radius from the center to each of these points. If I call this circle B, then each of these radius lines create or intersect the circle at points A and C and create what we call an arc. And that is called the intercepted arc. Now, what you'll notice is that this angle measure, whatever that angle measure is, will always be the same as this arc measure. So angle measure and arc measure end up being the same thing, are equal to each other when we have this, what we call a central angle. So for our blanks here, this angle, or this is the angle that an arc creates at the center of the circle. So to the right, we would call the angle ABC, and it is forming arc AC. And we would use the arc symbol like that to show that. Okay. And so these arcs are related to the central angles. And so another thing we want to talk about in this lesson is the idea of what we call the arc addition postulate. When I put all the arcs on a circle, it's important to understand what they would all add up to. And we've used the term addition postulate before, and that is always going to tell me I'm going to have an equation that looks like this. Part plus part equals whole. And so in this case, the measure of the arc formed by these 2 adjacent arcs, or the arcs that share an endpoint next to each other, would be the sum of the measures of those 2 arcs. So for example, if I've got this arc AD, which is 32 degrees, and I connect that to the adjacent arc DC, which that's a right angle, so that's 90 degrees for the arc. That would have to be the same total as this total arc AC. So the measure of arc AC would be 122, because 32 plus 90 equals 122. Okay? So we're going to try a couple examples. You'll remember from lesson 6.1 that if I use 3 letters for an arc, then it's either a semicircle or a major arc. And so if I use the arc WXU, I want the measure of arc WXU, I have to go from point W through point X around to point U. So I have to follow this path that is well more than half the circle. So it's not a semicircle, this is a major arc. The sum of this arc would just be these 3 arc measures added together. 80 plus 139 plus 66. When I add those together, you can check this with your calculator, but that should add to 285 degrees. So the measure of arc WXU is 285 degrees. For number 2, same idea. We want the measure of arc IK. This is a minor arc because I'm only using 2 letters. So I want to start at I, and I want to go the shortest possible distance to K along the edge of the circle. That would be this measurement. That arc looks like I should be able to take 114 and add it to this arc, but that arc is not given to me. So there's another way to look at this. IK is the minor arc. The major arc that has the same endpoints, I have all those pieces. Well, all of the arcs of a circle add up to 360 degrees. So I could just find my 360 minus these 3, and the leftover would be the minor arc IK. So if I do 360 minus 105 minus 40 minus 66, I should get 149 degrees. And so now we're going to move on to talk about some of those angles that we have in relationship to these circles and the arcs. The first one we already talked about are central angles. Okay, a central angle has a vertex, this first blank is vertex, at the center of the circle. And so these different angles we create today are going to be based on where the vertex of the angle is. So when the vertex is at the center, we already know the angle and arc are equal to each other. So this formula is going to help me on solving certain problems, that the angle measure is always equal to the matching arc measure. But one of the other types of angles we look at is called an inscribed angle. And we talked about this a little bit in day 6.1. An inscribed angle or inscribed angles have a vertex that is on the circle or on the circumference of the circle. So if this is the center of my circle, that's actually not going to be the vertex for this angle. The vertex of this inscribed angle has to be on the circle. So might look like that. And that is a different formula. And you can kind of tell if I were to do my central angle, that's bigger than this angle. So I'm getting smaller. The angle to arc relationship is definitely different here. This time, my formula states that the angle measure is equal to half of the arc. Now, another way of thinking of that is that the angle is equal to the arc measure divided by 2. Okay, half of means the same as divided by 2. And so before we talk about interior and exterior angles, what we're actually going to do is we're going to come down here, and we're going to do a couple examples of central or inscribed angles. As you work through these problems, the first thing you want to do is identify what type of angle it is. So for these first examples we look at, 3 and 4, the angle types have to either be central or inscribed, because those are the only two I've taught you so far. So again, this all depends on where the vertex of the angle is. The type of angle depends on where the vertex is. In this case, our vertex is R. This is the angle I'm using. That's where the question mark is. The vertex is R. R is on the circumference of the circle. So this is an inscribed angle. And the formula for an inscribed angle is angle equals half of arc. So this angle is going to be half of this arc. The problem is I don't actually give you that arc, but I give you enough information to find it. Now, there's another problem with the note packet. These are not accurate labels. We don't have a point H, A, or F anywhere on this picture. This first blank should actually be the measure of angle PRQ. And the second blank should be the measure of arc PQ, that minor arc. Okay? So in order to find either one of these, I have to know more information. Well, I'm giving you this arc is 96, and the other arc over here is 144. All three of these arcs should add up to 360. So I'm going to take 360 and minus the 96 and minus the 144. When you do that subtraction, 360 minus 96 minus 144, we get 120. So this angle, or this arc, I mean, is 120 degrees. So all I'm going to do is go to my formula here, and I'm going to replace the word arc with 120. So my angle is half of that, okay, or divided by 2. Half of 120 is 60. That means angle PRQ is 60 degrees, and like we just said down here, arc PQ was 120. Let's try number 4. As you look at number 4, again, it's important to look at where the vertex of the angle is. Every one of these angles has a vertex at U, which is the center of the circle. So these are central angles. And in a central angle, remember that that formula was angle equals arc. And so I can write that down, and I need to start with the formula. For a central angle, angle does equal arc. However, that's not going to help me because I don't have any expressions for any of these angles. The other important thing to remember about any examples where I have arcs is that all the arcs add up to 360, or part plus part equals whole. Now, all 4 of these arcs, if I wanted to do all 4 of these, they would add to 360. However, I only have expressions for 2 of them. From V to W is x plus 54. From W on over to X is X plus 144. But you need to recognize that these 2 arcs create a semicircle, which is exactly half of the circle. So they should total 180 degrees. So that's my whole amount. And the two parts are x plus 54 and then x plus 144. So I'm going to add those two parts. And by doing this, I need to combine like terms. X plus x is 2x. 54 plus 144 is 198. And so now I can solve this for x by first subtracting 198 from both sides, which is negative 18. You do get a negative x value. That's okay. Because when we divide by positive 2, we get x is negative 9. But your final answer is arc VW, this arc, which is x plus 54. So I'm going to take my negative 9 for x and add 54 to it, and I should get a total of 45 degrees for the measure of arc VW. So those are some examples of a central angle and then another one of inscribed angles. But we have two other angle types to look at. First, we're going to talk about an interior angle. Interior first. In an interior angle, this is formed a little differently. A central angle is formed by a radius connected to another radius at the center. Your inscribed angle, those were both chords, but the chords didn't intersect until they met on the circle. Remember, a chord is a segment that exists inside the circle only, from one endpoint on the circle to another endpoint somewhere else on the circle. Those are both chords, but they didn't intersect until they got to the circle. If I have two chords that intersect somewhere else inside the circle, that creates what we call interior angles. So an interior angle is formed when two chords intersect, but I need you to write this down. The vertex is inside, or vertex inside the circle. So it might look like this, where these two intersect inside the circle. Now that's not the center of the circle. The center of the circle is probably right about there. So they intersect inside the circle, but not at the center. So that creates some different angles. We're going to focus on one angle at a time. Let's say I focused on this angle. Now that formula, that relationship's a little different because that involves chords. There's actually two different arcs we're going to look at. There's the directly related arc on that end of it, but we have this opposite side arc that plays a factor as well. And so our formula is that our angle measure here, this angle measure, is equal to half of the arc plus the arc. And I mean these opposite arcs from each other, okay? So there's an arc, here's the other arc. I would add those up and divide by 2. And I need you to remember, there's another way of writing it. I could do arc plus arc all over 2. That's another way of thinking about the same formula. But what you're doing in this case, when I add two things together and I divide by 2, you're finding the average. Okay, you're finding the average of those two arcs. That's what that angle is. The angle is the average of the two arcs for interior angles. Okay, so there's your formula. We add the arcs, divide by 2. For exterior angles, it works very similarly, but these are formed differently. An exterior angle is not going to be formed by chords. There's two other kinds of segments we can use to intersect circles. Chords are all inside the circle, but exterior, that word means outside. So the segments that form outside of a circle are either tangents or secants. So if I have two tangents or two secants, okay, so a tangent would be like that, okay, where it intersects outside the circle. A secant would be like this, where it crosses the circle twice and intersects, has inside and outside. So if I did two secants for this example, it would work the same if I had two tangents, but two secants here, the angle itself is outside of the circle. When the vertex is outside the circle, we call that an exterior angle. My formula is this. I'm still going to kind of do the same thing I did for interior, but instead of adding the arcs, I'm going to subtract. Now, when it says far arc, that means it's the bigger one that is the farthest from the vertex of the angle. When it says close arc, it means the smaller one that is closer to the vertex of the angle. So my angle formula for exterior angles is that angle equals half of parentheses far arc minus close arc. So let's try a couple examples involving these. So we're going to skip around a little bit. Number 5, I'm going to skip for a second. We're going to look at number 6. Number 6 is probably the most difficult example we're going to look at because of the length of the equations. It's not that hard to set up, but there's a couple things you have to be careful of when doing these kind of problems. So the vertex of your angle is at C. Since the angle has a vertex outside the circle, this is called an exterior angle. And the formula for the measures of exterior angles is angle equals 1/2 parentheses far arc minus close arc. And the words far and close are relative to the vertex of the angle. So here's my two endpoints of my arcs. The far arc is this long arc from B to D. The close arc is the shorter one on the inside there. And then angle C is the angle here. So this is your angle expression. So I'm going to replace the angle symbol on this formula with 6x minus 7. And the far arc expression I'm going to replace with negative 16 plus 27x. I'm going to put my minus sign. And the close arc expression gets replaced by this, 14x plus 7. Now, this is a little bit of a problem, and I want you to be careful here. Since I'm subtracting the entire close arc, I need to actually put that expression in its own set of parentheses. Because when I subtract minus 14, that's not really a problem, but you need to be subtracting the 7 instead of actually adding it. That minus applies to both of those terms. And so it really needs to be thought of like that, or you can actually write it out differently when you get to that point. So my far arc is negative 16 plus 27x. And so I could write this as minus 14x minus the 7 total, because the minus applies to all of that. Okay, when I subtract, I have to subtract every term in there from its matching term in the far arc. And then it's just a matter of combining like terms. In order for us to find x and eventually find the measure of angle BCD, I have to get x by itself. Well, first I need to combine my like terms inside parentheses. So I take my 27x minus my 14x. I'm actually going to put that term first. 27 minus 14 is 13x. And then I can combine my negative 16 and my minus 7. Remember, we're subtracting the positive 7, so that's why I wrote it as a minus there. Negative 16 minus 7 is negative 23. If you're trying this on your own and you didn't get a minus 23 there, that's because you forgot to do minus the 7. And I still have 6x minus 7 here. Now, there's a couple different ways to go about this. I like to avoid fractions and decimals whenever I can. So I'm actually going to cancel the 1/2 instead of distributing the 1/2. Remember, 1/2 parentheses is like dividing all of that by 2, and the opposite of dividing is multiplying. So when it comes time to cancel this 1/2, I actually need to take all of this times 2, because that'll cancel the 1/2. And if I do times 2 to the right, I have to do times 2 to the left. On the left side, we actually distribute the 2 to both of those. 2 times 6x and 2 times minus 7 becomes 12x minus 14. But on the right side, you're not distributing anything anymore because the 1/2 and the 2 canceled. They're gone. So all I have left on the right-hand side of this is 13x minus 23. Then we're going to take that and keep solving. I'm kind of running out of room, so I'll come over here. To work through this first, the first thing you're going to do is minus the 12x from both sides. At least that's what I would do first. Making your equation negative 14 equals x minus 23. 13 minus 12 is 1. 1x I can write as just x. Now I can add the 23 to both sides. And negative 14 plus 23 would be positive 9. So x is 9. Okay, that's my first part of my answer. Now I can use that to find the measure of angle BCD. BCD is your angle. Okay, that's your angle out here, angle C. So I'm going to plug in my 9 for x into that. I'm going to do 6 times 9 minus 7. Okay, 6 times 9 is 54. And 54 minus 7 is 47. So that angle out there at C is 47 degrees. If at any point you need to pause the video here to copy things down or go back and rewatch and listen to what I'm saying, go ahead and do that. You have the access to do that with this video. Let's go ahead and move on to number 7 though. On number 7, we've got some intersecting lines here, and we've got angles and arcs. We need to determine where the vertex of the angle is. Well, these two lines intersect right here at point M. That point is inside the circle, so this is an interior angle. And the formula or relationship for interior angles is angle equals 1/2 of arc plus arc, where we add the arcs and divide by 2. That means I need to identify the angle and the arcs. The angle is formed right here with a vertex at M. The closest thing to that is this. Just because you see a degree out there with the 50 doesn't mean that's the angle. Arcs are measured in angles as well. This is the angle, 23x plus 5. So that goes in place of my angle symbol. One of the arcs is listed out here by the circle, -5 plus 39x. That's one of my arcs, and I have to add that to my other arc, which is just 50. Again, we want to combine like terms here. I have -5 and I have 50. That means my 39x is kind of by itself. I'm going to write that first. But then I'm going to add the combined like terms of -5 and 50 as plus 45. Again, I could distribute a 1/2 in there, but again, these are both odd numbers that would give you some decimal values. I want to avoid that. So what we're going to do is we're going to, again, multiply both sides by 2. On the left side, we distribute the 2. 2 times 23 is 46x. 2 times 5 is plus 10. But on the right side, the 1/2 and the 2 cancel. There's nothing left to distribute. That's all I have left on the right side, 39x plus 45. Now again, we're just in a place where we get x to one side. So I take the smaller one, do minus 39x from both sides. That gives me 46 minus 39 is 7x. And then I subtract my 10 from both sides. 7x equals 35 then. And divide by your 7. And x is 5. Now again, that's not my final answer, but that's what I need to use to find my final answer. They ask for the measure of angle LMK. L to M to K. That's this angle. So I'm going to do 23 times my x value of 5, and then plus 5. When I calculate that, 23 times 5 plus 5, I get 120 degrees. Okay. All right, there's a couple more we're going to do in this video together, and then I'm going to let you try the last 4, 9 through 12 on your own, and then I'll show you at the very end of the video what those answers should be. But we are going to try numbers 5 and 8 in the video first. So again, we're going back to identify the angle type here. In order to identify the angle type, you need to find out where the vertex of the angle is. The vertex of my angle is at K. This is the angle. Okay. Now, it can be a little confusing. This arrow is pointing to the angle. That's telling you this is the angle relationship. That means the 80 is actually this arc relationship. We'll talk about that in a second. Let's identify the angle type first. This angle type has a vertex on the circle, so it is an inscribed angle. And that angle to arc relationship, that formula is angle equals half of just arc. There's only one arc we're using here. And so as we go through this, we need to fill in what we have. Now, the angle expression is -4 plus 11x. So I replace my angle symbol with that. And my arc, the arc that is connected from one side of the angle to the other side of the angle, or in this case, the vertex, is actually 80 degrees. So that's my arc. So to solve this equation, we can actually do half of 80 pretty easily. Half of 80 is 40. So 1/2 times 80 is 40. This side is -4 plus 11x. We need to get x by itself, so we're going to add 4 to both sides first, giving us 11x equals 44. And finally, divide by 11. 44 divided by 11 is just 4, and that is our x value. And that's all we have to find in this case. You don't have to find the actual angle measure. We already know it. It's 40. That's your inscribed angle problem there. Let's try number 8. It looks very similar to this one. Again, we have angle JKL. My vertex of my angle at K is on the circle. This is another inscribed angle. This is your angle. which is 2x plus 17. However, this is the arc that I need to use, not 289. 289 is the rest of the circle. To find this arc, I've got to do 360 minus 289, so I have an arc measure to use. And if I do 360 times 289, I get 71. So the arc measure I'm using is 71 degrees. So again, for an inscribed angle, your formula is angle equals half of arc. Hopefully you can read that. Let me do that again. Let's try that again. Angle equals half of arc. The angle is this expression here, 2x plus 17. Sorry about the bells going off. The arc we just found is 71 degrees. Now, there's a couple of different ways you could do it. You could do half of 71, it'd be a decimal, or you can cancel the 1/2 by multiplying both sides by 2. That avoids using decimals or fractions. So I would do 2 times 2x and 2 times 17, giving me 4x plus 34. And then the halves canceled with the 2, and so we have a 71 on the right side. Next step is to subtract the 34, giving me 4x equals 37. 71 minus 34 is 37. And then we can divide by 4. Now, we do get a decimal answer here, and that's okay. It's accurate. 37 divided by 4 is 9.25. Okay, I'm using my calculator to get these, just like I would expect you to. So that's my x value. I can plug that in here, 9.25. But to find the measure of arc, kj, you actually don't need to plug in. We've already found that as part of the problem. That was 71, so I'm just going to write my answer there. Okay, so moving forward, sorry, I kind of showed you the answer there. I want you to try the next few problems. Try 9 through 12, the last 4 problems, 2 on the bottom of this page, 2 at the top of the next. Pause the video to give yourself time to try that. If you have your answers for these 4 now, if you need more time, pause the video. But otherwise, these are the answers you should get for 9 through 12. Number 9 is an interior angle. Okay, so we add the angles, divide by 2 to equal the arc, or angle equals half of arc plus arc. So we add the arcs in here, and that's the angle. We should get x equals 5, and when you plug back in for this arc here, you get 63 degrees. Number 10, this is another exterior angle problem. Again, angle is half of arc minus arc. Far arc minus close arc. Well, this is my far arc, 19x plus 29. This is my close arc, 7x plus 19. So when I subtract minus that, it actually becomes minus 7x minus 19 in my formula here. When I solve that for x, I should get x equals 12. And when I plug back in for my angle here, I get 77 degrees. Okay. And then finally, these last 2, number 11 is another central angle. Again, angle does equal arc, but this goes back to our problem that we did at the very beginning, where I'm really looking at just the parts adding up to a semicircle here. Okay, I have another semicircle, 180 degrees. So the 2 parts add up to equal 180, and x is 9. And finally, number 12, that's another inscribed angle, where the angle is half of the arc. Okay, angle equals half of arc. And in order to set that up, the angle is 7x minus 10, but I need to figure out that arc by subtracting these other 2 from 360. And so that arc is 106. So I plug that in for my arc word here, and I end up getting x equals 9. And when I plug back in for that angle, that was 53 degrees. Okay. Well, that finishes our lesson for 6.2. If you have any more questions, make sure you come see me in class or send me a message through Canvas.